All right, gals, any livestock, anybody else on the line here? Hey, this is Bob Sullivan with Pureline. I'm being joined by Greg Boba. Greg, as anybody who's been on the previous webinars, works with Johns Hopkins. This is our final presentation in a series, so it's our fourth one. And at the end of this, I'm going to remind you at the end also, but at the end of this, you'll see a email address for Alex Whitmore. You want to make sure that you email Alex Whitmore your contact information, because we're going to have a drawing for the HP chlorine dioxide system. This has the HP chlorine dioxide system has a value of about $100,000. So it's certainly worth everybody's time. We're also going to have a second place win. If anybody is, watches chlorine dioxide like we do, you've got a gentleman named Greg Simpson. Greg Simpson has been with Pureline, I don't know, Greg, probably going on 10 years at least of knowing of you and X number of years working here. But Greg's written, if you ever go on Amazon, has written several books. In fact, he just came out with his third book. So there's a volume one, that was volume 3. That's a new one. There's volume 2, and then there's also volume 3, which is so new you can still smell the print on it, okay? But we're gonna make that as a second prize. It's very, very good information if you really wanna understand some of the ins and outs of chlorine dioxide. Okay, so with that, I kind of stalled a little bit so that everybody get online and get comfortable. Let's go ahead and get started. All right, so webinar number 4, we're going to talk about Legionella sample history and Legionella prevention and control. Now, most of this dog and pony show is going to be Greg Boba. I'm going to turn it over to him here in just a few seconds. All right, so Greg, why don't you go ahead and start us up?
Sure. So, a lot of people looking at, Legionella where it grows, and most people are focusing on hot water systems. But the fact is that we have treat both the cold and the hot water systems because it does come in from the city water supply. While it's hard to detect, we do see it in strainers, things like that. So we do sample the cold water main. Next. And so we also sampled the hot water supply in return. So what we do is downstream of the converters, we grab a water sample and on the return main. This kind of tells us really what's happening with the piping system, not necessarily the distal sites, but the system itself.
Greg, can I ask you a question on that?
Sure.
With 36 years of experience of boots on the ground on this, hot versus cold lines, is there any probability I'm going to more likely see it in hot or cold? And where am I likely to see it? And I know you're going to cover some of that, but.
Well, I'll cover that, but this next item really identifies it. So you can have a contaminated piping system and not detect it at sinks and showers. So you can have a grossly contaminated mains. The thing is that Legionella and other waterborne pathogens like Pseudomonas mycobacteriums will hide in the biofilm, and they'll grow and grow and grow, and then they slough off, and that's when you pick it up at the distal sites. So, that's why it's important to look at both the mains and those distal sites, so that you can detect whether or not you got a system-wide contamination or just a distal site.
And what's your thought? I know you guys, because the way you treat your success, you haven't seen much, but our average run-of-the-mill hospital is just getting going. Are they more likely to see this in hot or cold water systems, or is it just so random we don't know?
Well, here's the thing: testing's not required to do. Basically, as people say, well, I'm not testing, so my water system's clean. And it's not until they have a patient problem is when they test. Other institutions like us, we are testing as a preventive measure. Okay. So, typically you get a positive testing of a distal site. Now, you don't know whether or not it's the hot or cold water, because the hot and cold water connects to a faucet, and then the water stream goes through an aerator, and then, and then into the environment. So, you can have a contamination of the cold water system and not the hot, but commonly people focus on the hot.
Okay, great,
Right.
great.
So,
And is that a wise move, just to focus on hot, or?
no, both. And so that's why we focus on the cold water main, specifically for the main. So we do the beginning and the system, and the hot water supply, downstream converters, and the return main. And that tells us what's going on in our piping system. So then we go to sinks and showers at the end of the water system per each floor. And this is hot and cold water. So you've got maybe 18 rooms off of a riser, and we will grab the end of that particular branch main and grab a sink, 2 sinks, 2 showers. And so keep in mind, this is in this particular case, the building I'm going to be talking and focusing on, there's over 3,000 plumbing fixtures. Now, we only do maybe 150 fixtures of those per quarter. So, I'll talk about the positivity rate, but that, we're doing more testing than what's recommended and what's being utilized out there, but we're still could miss it.
Greg, I have a question for you from, and again, I have a friend named Tamara, but some people go by Tamara, so I'm not sure which pronunciation. She asked the question, if your facility has wells on site and the water doesn't travel for miles through water mains before it reaches your building, is it less likely to have Legionella at the point of entry?
Well, it depends on the well. I mean, I know that there was a patient issue here that the patient had Legionella. They were blaming the hospital. So we went through all this testing and we did not find it in a water system. And then when we speciated what the patient had versus what we have seen here, it was a totally different species. So they went back, found out that this patient was from Pennsylvania, and the patient was on well water. And so the well water may have it, but the magnification and could be, once it enters the building, the hot water system is not being utilized. The temperature is perfect. So, it varies water system to water system, but it's a common found bacteria. Just that for the regular healthy people, it's not an issue. That's why city chlorine levels are such for the healthy, not for the sick.
Got it. Greg, and another question. This is from Austin. So would or could you use the testing of both the hot and cold to eliminate the main as the source?
You could, okay, but the whole thing is, because you're only testing a small percentage of the fixtures, this sites, you need to test both the cold water main, the hot water main, and the distal sites. You have to look at all the information.
Okay, thank you.
All right, next. So what water ice dispensers? Now that has been a concern because ice dispensers and water dispensers, all the patients here do not use a hand sink in the bathroom for water. Okay, they go to a pantry and get their water. Ice dispensers, make ice cubes. Okay, and so you put ice cubes in a drink, but you could aspirate the ice cube into your lung, and if it's contaminated, you can contaminate the lungs. So what we did here is that we tested numerous filters to remove oxidants, chlorine, things like that, that could make the water and ice taste kind of funny, but you're not protecting the ice water dispensers. So we established an extensive maintenance protocols that exceeds the manufacturers, and that this is to disinfect and clean the water path and the ice path. This is the ice bends, you name it. And so once we implemented the filtration and extensive maintenance, as well as elimination of any plastic tubing inside of these machines, because a lot of machines have plastic. We have copper tubing, so it's a hospital grade equipment. And Follett is one of the manufacturers that now has a hospital grade equipment, and we have not seen any problems with these. So we don't routinely test these equipment primarily because of filtration and the maintenance.
And Greg, can you give us just a sample of type of maintenance that you do on the ice machines? Just any of them? Like, what do you do? A tear down? How do you do the machine?
Yeah, what happens is that the equipment follow the manufacturer's recommendation and uses a descaler and a disinfectant. And we don't deviate from what they recommend. Okay. And so they will install ports, and we will flush through the whole cycle from beginning to end, just to make sure it's clean. Now, one thing that people don't know that, they test these machines at the factory and they ship them, and they can be contaminated. So if you don't decon the equipment upon putting into use, you can have a problem and have a growth of some kind of bacteria or Legionella or something like that. So, it is a pretty multiple step procedures in addition to what the manufacturers recommend.
Great, thank you.
All right. So detection levels. Now, if you follow the current guidelines, it's like 30% positivity rates. When you're below that, you just monitor the system. Okay, so that's 30% of maybe 5% of the fixtures you're testing. So we establish a zero detectable level. So what that means is that every test site must not have detected Legionella, because one fixture could mean you have 100 contaminated fixtures or 1,000 contaminated fixtures. Like a state in this one particular building, we got 3,000 plumbing fixtures. And if you allow any detectable limits, you can have a contaminated site that you're not testing.
Great.
Now, actually, there's something else I want to add to that last part, is that culturing. A lot of culturing is done as direct plate culture. And what that means is you take the raw water and you look for Legionella. We do that, as well as concentrated plating. Now, direct culturing, anything less than one commonly forming unit, is reported as a non-detected. So we do a concentrated plating, which is filtering off the water. And you may destroy some of the organisms, but that will let you know if you have one or less colony forming units. So we do both testing methodologies, which, I don't know if it's recommended to do both, but we do. All right.
Okay.
So,
I got a question.
Sure.
I have a question for you, if you like. In a hospital, you also have all kinds of machines in the kitchen, beginning with coffee machines, ending with juicers, etc. You talked about the ice makers, but did I get you right that you recommend to do the decontamination of all these regularly?
Well, like ice machines to coffee makers, typically we put a filter system on it. So mostly to filter out the carbon, chlorine from the water supply. So, who wants to have coffee and have that slight taste of chlorine in it? So, our kitchen processes have filter systems installed to remove sediment, and also in certain applications, carbon filters to remove oxidants. All right. So,
Thanks.
so one of the things that we looked at was a startup and remediation. And one of the things in the years of experience here was that when we first 20 years ago, we started looking at chlorine oxide. And so you put it on and wow, it should work. Well, there's a lot of things associated with it to make it effective. So, a water treatment system is just a piece of the puzzle. But the startup is very important, and it accelerates the use of the disinfectant and cleans the piping system. So all aerators are removed and all that. In this particular case, in a new building, which is 1.5 million square foot, all the laminar flow devices, we use those in place of aerators because we don't want to aerate the water, are removed. And we do a flush remediation at 5 ppm. Now, the reason why we use less than 5 ppm, and that's parts per million, is that it's testing equipment. We don't know what the levels are. So, we know we can detect 5. And at 5 ppm, we can, in an hour, we can flush the system. And so when you use chlorine or monochloramines, you put a certain dose in a system. It could be 50 parts, 500 parts per million. You put it in a system, you measure that thing, and you turn the water off and you let it sit. Now, in an occupied building, it's a problem. In an unoccupied building, you could do that. But if you have an occupied building, do you really want to shut the water off for use for 4 hours, 12 hours, 24 hours? So, Bob, what we developed here was that by using 5 parts per million chlorine dioxide, you put a restriction: don't take a shower, don't drink the water from a non-filtered water source. So an ice water dispensers can stay operational, but you can still use the toilets, flush the water, wash your hands. Okay. So, you use about a pencil stream of flow as a startup. And then, you test before and after the remediation or startup, and, and you record those values. So it's a very effective startup tool in addition to the requirements of the in the state of Maryland, it's required to use the chlorine, but there's no requirement for chlorine dioxide. It's something we do in addition.
So Greg, let me give you some color commentation on that. This is not about hospitals, not about Legionella, but Dr. Simpson and myself, we run into a lot of industrial customers, and they have miles and miles and miles, in many cases, big pipe, sometimes up to, a meter or 3 feet in diameter. And they're new to chlorine dioxide. They've had their pipe system forever. They said, hey, we've been using it. It's not really, this other chemical is not really working. Can we do chlorine dioxide? So when we start off, they're looking for that little bit of residual to show that the chlorine dioxide is being effective. The problem is, in those industrial applications, many times these pipes are so fouled that it can take 1, 2, 3, 4 weeks, sometimes 3 months if they're really bad, to eat all the way through all that biofilm and all the stuff that has developed on the perimeter of the pipe, to get it all eaten away so that you can start getting a residual. We just saw that out in Oregon. We had a customer call and go, we're not seeing a residual. We're not seeing a residual. It probably took them 6, 8 weeks before they saw the residual, and we kept turning the machine up. Now, again, these are not hospitals, but the idea is to demonstrate to you that when you get in the system, remember, chlorine dioxide goes out, it kills something that it finds, that needs to be destroyed, a pathogen, et cetera, and it destroys itself. So if you enter a pipe with, say, 5 parts and you got 20 parts of bacteria, that's a hypothetical, of course, between here and 100 feet, well, that 5 parts isn't going to go very far. Then you put another 5 parts in, then you put another 5 parts, and eventually you start cleaning up the pipe. So that's just so you understand how it works and how the chlorine dioxide works in pipes, especially in these long runs, and especially if you're just starting with it, what you need to do to really clean it up.
Yeah, we had some old buildings that they were not treated for 30 years and galvanized pipes. So you had a lot of corrosion buildup in the piping. And, it took a couple remediations at 5 parts per million. And when we approached 7 to 8, we started sloughing off so much biofilm that the water color changed. And so we backed it off. So we did not cause a major disruption. But, the older the pipe is, you may have to go to multiple startups. All right.
Very good. Thank you.
I have a comment. This is Greg Simpson. The other caveat that you got to be careful about when you're running these industrial pipes that run for long distances, if they have never been treated properly, It may be the scale and biofilm that's plugging the holes. And so when you put chlorine dioxide in there, you got to warn people up front that they when they start moving that stuff, they might turn their pipe into a pincushion.
Well, Greg, I'm glad you brought that up. In our old piping system, it was the scale that was plugging the holes. And we did ultrasonic testing of piping and found that the piping was like 80%, 90% eaten away. Okay. But the corrosion in pipe made one think it was thick, but the actual steel of the pipe was thin. So when you remove the biofilm, you will have leaks in old systems. So what we did was these older buildings, we budgeted money for main replacement because we knew we were going to have leaks. Now in a new piping system, you don't have a problem because you don't have the biofilm and all that associated with. But yeah, you got an old system, you're going to have leaks. It's not that the chlorine oxide is eating the piping, you're removing the stuff that's blocking the pipes and the holes.
All right, so I've got another question for you here, Greg. Again, from Austin, how do you select the testing points? By the risk level of the patient population or some other method? Also, do you rotate the test points to eventually get through all distal outlets in the system?
Okay, so this testing we're doing is not a patient-related testing. It is a maintenance associated testing. So what we do is, like I stated before, we test the cold water, hot water supply and return. The picking of distal sites is strictly on how the piping distribution system is laid out. So typically you got a riser and you got to branch off the riser to the end of the floor. We picked the 2 bathrooms, patient bathrooms at the end of the floor. Has nothing to do with patient census, anything like that. So if you have a 6-story building that has 6 patient levels, we will grab 12 sites. So in a small building, like in one of our buildings that we started testing in the hospital 20 years ago, we picked every end of run, every patient floor. So if you pick the typical sites, you may do 5, 10 sites. We do about 30 sites. So, if we have a patient concern, we'll test that all the sites in addition to that patient room. Okay. But this testing is strictly on a non-patient incident. Did I answer the question?
Yep.
Okay. So, 6 hours. Okay. 1 hour per floor. Well, you can typically do it in less than that. But what we did years ago is that we tested before and every hour on the hour. And we found that about 1 hour, you clean a floor. So 6 hours gives you a time to do each floor. So the total time of a remediation and startup is about 6 hours. All right. So the hot and cold water, we flush at all sinks. So basically is we treat the main coming in, and at each sink, we turn the water on hard, that's hot and cold, and then we back it off to about a pencil stream, and we run that for about an hour. Toilets and showers, toilets you flush, as you do around, so they may be flushed 2 or 3 times an hour. But, majority of the flushing is at the sinks. And the showers, the reason why you don't run those a lot is because you don't want to flood. All right. And once again, flush showers periodically. All right. So what are restrictions for drinking the shower only? And you can flush toilets in the hand wash. This is on remediation processes. And we did a chlorine treatment of one building, superheating, very costly, downtime. We had a hand carry water, develop water stations. It's very disruptive. By using the chlorine dioxide, our disruption is really, hey, you drink from the water ice machines, and you don't take showers. So it's very minimal disruption to the patients. Well, the complaints we get were of, geez, I hear this water running, I got to go to the bathroom. I mean, that's the level of complaints we get. So what does it really mean? So here's one of our new buildings that opened up in 2012. And we tested to date over 3,856 sites. Now, this is direct and concentrated plating. And in the beginning, we had one site of 20 CFUs of Anissa, which is a non-Haemophilus species. And it was a sink in a non-patient area that we forgot to flush. And this before occupancy. So you can see that each year we do about 412 sites, and they've all been negative. And this is phenomenal. I mean, a lot of people say, oh, it doesn't work. This is 1.5 million square foot building with 3,000 plumbing fixtures, and we test 412 sites typically a year, and they're all been negative. And this is at zero detectable levels. It's not, oh, 30%. It is zero. So it is a phenomenal remediation system. And, of course, this is in combination with, good water flow, maintaining 112 degrees, not 140-degree hot water system. It's improving the maintenance of these systems and showers and the like, elimination of aerators and put in laminar flows. But the key element is the chlorine dioxide. It is a preventive measure for a very sick population. So, we found, looking at chlorine dioxide, it's been a very successful treatment system. I mean, I'm not just talking about a year's worth of testing. It is over 21 years of use. And we currently have 5 buildings being treated with this. And 4 of the buildings we've been treating probably, I would say, since 94. So, that's when we started, looking at it. And in 2004, we went to full operation in all of our patient towers. And we only treat patient towers because the patients are here as a patient for more than 3 days. So patients of risk, we do urine antigen tests, looking to make sure they're disease-free upon admittance. And we are responsible for that patient's environment, that's air and water, while they're here. And so that's why we extensively test the water to make sure it's clean to these patients. And then what we found is all of our patient buildings that we have treated with the chlorine dioxide, we have not had any Legionella issues in these buildings.
That's amazing after all those years, Greg.
Yeah, it's phenomenal. It really is. And so, the selection of faucets, I think in previous webinars, I mentioned about, the elimination of electronic faucets and using manual faucets. And it just because of, that we eliminate the possibility of stagnant bodies inside these faucets. So the proper selection of faucets and the flow rates is very important. A lot of people are going to the LEED, the green buildings. And if you look at green buildings, the flow rate is like 0.5 GPM. Okay, that's total. That means you got 0.25 hot, 2.25 cold possibility. It's very low. So all of our patient rooms, we have 1 GPM. So basically is by having laminar flow and at these flow rates, we're able to get bad water out and good water in. And, and we forego the points associated with, saving water because the safety of our patients was more important. So equipment and system design, I touched on a little bit about that, but we filter the water for 20 microns and above. That's a sediment and debris to try to keep the systems clean. And then, we put filter systems and carbon systems that are designed for their flow rates. The hot water systems, we redesigned the manufacturer's recommendation and engineer's recommendation and design. We changed out the diverter flow valves, the size of the piping, so we have good circulation in the hot water system. These are critical that regardless if you're treating a system or not, it improved the performance of the system. As an example, before we modify the hot water system in this brand new building we're talking about, that it took about 45 minutes to try to get 100 degrees, 112 degrees at a faucet. Once we did modifications to the return water system, the hot water system, less than a minute, anywhere in the building, we got 112 degrees. So proper system design and selection of equipment is critical, just from an operational standpoint, but also, from a growth control.
So guys, we're getting near the end of time, but we're going to go over a few extra minutes. I do have a question that require both Gregs to answer from different perspectives. And the questions comes from Tamara. How long after flushing will it take for Legionella to start regrowth in the system? And Greg Bova, I want you to answer, but Greg Simpson, we did some work with biofilms on how fast they grow. I think you did some work up at Montana State. So I'll have you comment after Greg Bova.
Okay, so we wanted to know that ourselves. We wanted to know whether or not do we need to run the system periodically, continuously, so forth. So we did a flush remediation, tested the water system, got all negatives. Then we turned off the chlorine oxide system. And every week we tested. And in 3 weeks, we started to see some growth. So that told us that we can safely have a system off for 3 weeks before we see growth in a system. So, but the end of story is that because of that potential growth, and this is all depending upon whether or not the city water quality is such that it's Legionella free or not. So, if a system's down for 3 weeks, we will do a remote remediation of the system and flush, just to keep it clean. But typically it's about 3 weeks.
Great. Dr. Simpson, you want to talk from your work at Montana State?
Okay. As I understand it, Legionella is an organism that's a little bit unique. The way these organisms compete in nature for nutrients and survival is they put out antibiotics that are toxic to competing organisms. Legionella has not been found to be one of those organisms. So it's kind of like the 90-pound weakling at the beach that gets beat up all the time. And so the only way it can survive is in protected niches, like inside of an amoeba, which is a higher life form you wouldn't find in a hospital, in cracks and crevices, but primarily in biofilm. Biofilm growth is very much a function of bacterial nutrient. Chlorine is really bad at controlling biofilm. The issue is chlorine's been used for so long in these industrial plants for biocide as cooling water, is that the reason it can work effectively is that the biofilm growth is so slow. I've done work in one plant where it was a methanol plant, and they were feeding chlorine and had been for years, but they could never get a chlorine residual because the biofilm was growing faster than the chlorine could remove it. But we put chlorine dioxide in there, and it knocked all the biofilm off. So I would say it depends very much on the function of how much available nutrient is in the water for other bacteria to grow and create a biofilm. And I guess in Greg's hospital, Greg Bova's hospital, it was about a 3-week period. Does that help?
That's excellent. Thank you.
Hey, I'd like to add to that. Back in 2000, 2001, and we published this information, that we had a building that we did extensive testing before and after startup. And this was learning, how do you operate the system? How do you control it? How do you treat? And what we found was that we had a low Legionella positivity count. and a high positive count of gram-negative bacteria. And so after the period of weeks, it flipped. We started seeing a lot of positive of Legionella and very little of other bacteria. And the reason for that is that Legionella is a little harder to kill. So it was competing against fast replicating bacteria. And so it showed up, it was more prolific in its thriving than Legionella. Once we eliminate the competition, Legionella had room to grow. And so that count went up. And so we increased the dosage and the treatment aspects of the chlorine dioxide, and we eliminated the Legionella. So, one is, when we look at Pseudomonas mycobacterium, they're easier to kill than Legionella. Okay, so if you see high numbers of those, very well, Legionella is hiding in the background.
Great.
All right, so daily flushing. What happened was that we found that we were getting like a 97% reduction in Legionella, but we always had this 2-3% positive rating. So we instituted and tested a daily flushing of sinks and showers and flushing the toilets. And the reason why daily came about is people were in these bathrooms cleaning them, and they're in there for 15 minutes, if they're properly wiping down the walls, the sinks, cleaning the toilets and the showers. So when they're there, flush the toilet, turn the water on, let it run a little bit while you're cleaning the sinks and the mirror, turn the shower on, and when we did this, it eliminated that 2-3% positive rating. So we have instituted in all the patient rooms of a daily flush while cleaning. And there's a log kept of this work to make sure it's done. And once we institute it, as the chart I showed previously, it eliminated any positive growth.
So question, can polyorthophosphate coating harbor Legionella?
I
Dr.
don't know.
Simpson? Yeah, that's probably Dr. Simpson if he knows.
I don't really know the answer to that, but I know that orthophosphates used a lot as a corrosion inhibitor. Certain polyphosphates are also used as potable water corrosion inhibitors, and they can react with calcium under the right conditions and form a deposit, typically in areas where there's a lot of turbulence. Maybe that's wrong. I don't know, but it is possible for Legionella to grow inside of a deposit. So in a sense, I would say the answer is possibly, but I haven't seen anything in the literature that talks about that. So I can't really speak authoritatively.
Maybe an idea for a fourth book? Go ahead, never mind.
All right, so the one of the most important things we've done around here is extensive Legionella water testing. So as I stated earlier, that you test the water coming in at the end of the cold water system, the hot water supply, the hot water return. You pick distal sites at the end of a branch main, and and these are maintenance cultures. So if there are positive results, detectable results, you don't have to report it to your state or to your local authorities, because these are maintenance, non-patient associated samples. So, while we may see of course, I'm going back 15 years ago, when we used to see positive testing samples, we didn't have to report it. We just did a local remediation. If we saw multiple positive readings, we may do a system-wide remediation. But like I stated, last time I recall was over 15 years ago, we've done some kind of remediation. And the detectable limits, that's very critical. Don't be conservative, should say be conservative. Use a zero detectable Legionella limit, because you're only testing a small portion of your distal sites, your fixtures, your sinks, your showers, your ice machines. So by having 0 detectable limits, any detectable limits out there makes you want to look at the system deeper. All right, so that's critical to do.
I have another question. Do you have, do you ever have you ever done experiments on water coming in that was still contaminated by residues of hormones coming from wells near contaminated rural meadows? Does CO2 also eliminate such hormones?
Well, you know,
Dr.
I don't know about the hormone aspect. I do know that we get our water system or water supply from a rivers that goes to reservoirs, and then that's where they filter and treat, and they use chlorine. The Baltimore City backup water system is from the Susquehanna River. I know that back in '07 there was a drought, and Baltimore City was pulling about 30 to 50% of its water supply from the river. Now, unfortunately, I was taking a little bit of leave at the time, so the guy that was overseeing the farm wasn't paying attention to what was happening. And so what happened was that the Pennsylvania Health Department issued a bacterial warning for the Susquehanna River. Now, you could smell river water, you know, in Baltimore City, and it had Legionella, and there was a lot of positive results in the water supply. You know, there was things that could easily have been done, and they were corrected once they called me up. But you know, but we do know that you can have problems if you don't watch the quality of the incoming water. So as to wells, you know, we're not a well water system. I cannot answer that question, but I can answer, you know, I hope I did, related to how we get our water, which is from reservoirs. All right. So the last part is chlorine oxide startup remediation. Startup is critical. We had a facility in a Hopkins hospital that the director decided not to do the startup protocol that was provided, and you hooked the system on, and geez, I'm getting positives. You know, did you do a startup? No. Well, why not? I didn't want to do it. So they end up starting over again, did a startup, and they got negatives. So the startup has proven itself to be very effective to jumpstart any cleaning of a new system and an old system. And remediation process is critical if you have any positives relate to a patient or your testing as a maintenance aspect. But the critical part about the chlorine dioxide is you don't need a complete water system outage to do a remediation as you would need to do with using chlorine or monochloramines. So, you know, your disruption is minimal, but very effective. All right, and that's all I have to add. So any questions, please send them to Bob, and Bob, you can ask me.
Well, Greg Bova, first of all, and Greg Simpson, Dr. Greg Simpson, this is the end of the fourth series. I'm going to remind people of a few things, but I want to thank you guys. This is unbelievable feedback. I mean, to have, you know, the technical assistance of Dr. Simpson combined with the boots on the ground from Greg Bova, I can't tell you how valuable this was. Now, for some of you that are online, maybe you missed session 1, 2, 3. You can find those on YouTube. If you just search Legionella and Pure Line, you're going to see those different, and including this one will be included later. But you'll see all 4 of those. I would tell you number 3 and number 4 have the most information in terms of boots on the ground information. The first one is more about Pure Line and who we were. The second one were some of the basics on Legionella. It all depends on where you are on all of this. Now, today, if you don't mind, we're going to be setting up a drawing to give away that machine. We're asking for the deadline, as you can see down by the 3rd bullet, for submission is today at 2 p.m. Central. So basically, in another hour here, actually in 15 minutes, we'll extend it, guys. We'll go to 3. But, you know, in another hour here, then we're going to get all that together and we're going to do the drawing. basically probably on Friday, and we'll be in touch at the beginning of next week for anybody who won the generator or the much prized Greg Simpson books. So with that, I would like to say thank you to everybody for a great series. I might have another question. This is from Austin. Do you have any data regarding what % of hospitals nationally perform regular testing for Legionella? I do, because we call them all. And I can tell you that the number of people that are doing any type of Legionella control is still in the minority. When we did and this is us talking to hospitals over 100 beds, so that leaves you about 3,700 hospitals just under that number. And of those 3,700 hospitals, the majority do not have Legionella control. We were about 1 in 5 about a year ago did have them. So I don't know if that's helpful. Now, some people say, well, yes. I mean, here's some people's idea of control. Oh, yeah, we have it taken care of. We get city water. I go, what? Well, it's chlorinated. What? So some people, I guess you count the people who thought they have it versus the people who really have it, the number might go up to about a third. But I would tell you have 13% of those of that number is kidding themselves.
Hey, Bob, I know why people aren't testing. It's not required.
Yeah.
So, people say, why should I test? It costs $85 to $100 a test. And so unless I'm mandated to test, I'm not going to test. And that's why people don't do it.
Yeah, no doubt. Thank you, Greg.
Sure.
Okay. With that and no more questions, I'd like to thank everybody for taking the time. It has been a pleasure to do this. If there's anything Pure Line can do for you, you certainly have our contact information here. That's my cell number. I don't really use an office number anymore. And you certainly have Dr. Simpson's number on here. And if you want to get in touch with Dr. Greg Bova, you just give us a call and we'll get you all hooked up there too. Anyway, thank you very much. Greatly appreciated. Again, thanks to all the panelists.